So I'll briefly go over REST APIs. And REST APIs are the most common type of API protocol, and we would really would be one of the ones that we cover in depth in this lecture. And so the diagram here shows kind of like a high-level overview of how REST APIs work. The HTTP requests in the form of web URLs are used to perform create, read, update, and delete CRUD for short operations. And then for each request, after the client sends this request, a response is sent by the server in different formats containing the information that the client asked for. And so this response can be in JSON, which is one of the more common ways that this is sent back, HTML, XLT, Python, PHP, or even in like a plain text format. There are 6 basic principles of REST APIs. The first one being the client-server architecture, which we have already kind of briefly covered. And so RESTful APIs are built with a client-server architecture, which simply means that the client sends a request to the server and the server sends back a response. Another principle of REST APIs is statelessness, which means that the API is not storing any data or statuses between the request made by a specific user. And so for every request that a client sends, the server will complete this completely independently of all other previous requests. So for example, if you're trying to make a request to a server, you cannot make one based on on the assumption that the server is going to remember a previous request that you made. Another principle is cacheability, which basically means that resources should be cacheable on either the client or the server side, so as to reduce the load on the load on the server, and so fewer requests can be made and help to improve scalability. And so the server responses must indicate if caching is authorized for the offered assistance on the client side. And caching basically just means like making a temporary store of the request. And so if you're trying to if you're trying to request the same information over and over again, you wouldn't need to do so. You would just cache a copy of the response and then use it in the future client request. A layer system is an application that is made of various hierarchical layers, where each layer has information about only itself and no other layer. And this is another principle of the REST API, in the sense that in REST, the client interacts with the server through a single endpoint, and the server provides a response, although it may be interacting with several intermediary layers. And so these intermediary layers could be, for example, like a proxy between the client and the server to improve scalability or security, or it could be like a security layer to enhance the system safety. And so the way that the layered system works is that there's a separation of concerns, and this makes it easier to change these backends and these backend systems, perform maintenance, and change the existing ones without really affecting how the client is interacting with the server. Another principle of the REST API is a uniform interface, which means that the API is using a common set of methods to access its resources, and is doing so using a standard format, either using the JSON or the XML like I described earlier. And for giving these responses. And so all the API requests that are asking for the exact same resource should look exactly the same, regardless of like where they're coming from. So if I want to access a specific gene set that is saved in the database of an application, and I'm trying to use an API request to get this information, the request that I would write today and tomorrow, and the request that I would be writing and somebody else who's asking for the exact same resource should look exactly the same. Another principle of the REST API is code on demand, which is an optional characteristic. And basically this means that like for every description that I've given earlier, it's basically a REST API is providing a static response. So this could be like a database entry. But in rare cases, these responses can be executable code that can be executed by the client instead of just like sending back some data. There are four basic parts of an API request. And so we have the endpoint or URL, the method, the headers, and the body. And so the endpoint or the URL is simply the URL location of where the API would receive a request. And so this could be, for example, like example.com/add list, example.com/enrich. And the method, on the other hand, is the intended action of the request. So this can be like post or get. I'll cover exactly what each of these mean in the next few slides. We also have the headers, which are property value pairs, which are separated by a colon, that let the client and the server pass additional information with their HTTP request. So for example, you can add like authentication tokens or like more information about what kind of data is being sent to the server. An example here is the content type header, which tells the server the data type of what is in the body of what is in the body of the request. So for example, here we see that content type application/JSON header, which will tell the server that the body of the request is in a JSON format. We also have the accept header, which specifies what we want, like the kind of data that we would want to be in the response body. And so here we like at like so for here we see accept application/JSON. And this would basically specify to the server as we're sending a request that we want the response that is being sent back from the server to also be in a JSON format. Then in the data or body would simply okay. The data or the body would simply contain the information that you would want to be sent to the server. So for example, if you want to send a gene set to be added to the database, you would send this in the data or the body of your API request. And so the data or the body is only really an option for post, put, patch, or delete requests, mainly because for get a request, we are asking to retrieve data. And so we're not really being expected to send any data for this. So going more into detail about the HTTP REST methods. So the REST methods, like I said earlier, are the intentions or meaning of a request, and these are used to perform CRUD operations. And so the get is used to retrieve the resource representation. So it's basically if you're trying to read a particular data object that is in a database that the API is using. And all GET requests are idempotent, which means that the same GET request should return the same response at all times, even if you're making these requests in succession. And so, for example, here we see this request URL to view and add a gene set in Enricher. We see here that we're specifying the user list ID, which is basically a unique identifier for a gene set that has been added to the Enricher database, and we're specifying it in the query parameter. So using this question mark followed by the parameter that we're trying to specify. So here we would be using a GET request to get this particular gene set of reviewing that has the user list ID 363320. A post request, on the other hand, is used to create a new resource in a collection of resources on the server. So for example, if we wanted to add a gene set to the application database, like creating a new gene set that did not exist in the database beforehand, we would use a post request to do this. Pull requests are used to update an existing resource. So if we want to update the object that is already saved there, we would use a put request for this. Patch requests, on the other hand, are used to make only partial updates to an existing resource. And so put requests must contain the whole representation of the resource that we would like to update. So for example, if a server database has information about users that collects their name and their emails, and I want to update someone's email in the database, I would send both the name and the email in the pull request to make this update. And so because of this, pull requests are idempotent, which means that for every pull request you make in succession would basically return the same resource back to you. Patch requests, on the other hand, contain just a subset of the data that we would want to update. So for example, if we're sending a patch request to do the exact same thing, we would only send the email attribute in that patch request. And so in this sense, patch requests are not necessarily idempotent, but in most cases they are. In an example of a case where they're not idempotent would be when we're trying to like make an increment of an attribute, or like say for this particular field, add 5 to it for every patch request. And so in this case, we would be getting a different resource with every request that we make, which means that particular patch request is not idempotent. The delete operation, like its name, is just used to delete resources to delete resources on the server database. And so for this, we would be sending the information about the resource that we would like to delete. So for example, a unique ID for that resource in the database. And then we have the head request, which is similar to get, but this would only return the status line and the header section. So this is not as commonly used, but please pay particular attention to get, post, put, and delete operations, as these will be coming up a lot in the documentations that you'll be looking at. So the parts of the HTTP responses. So there are 3 parts. There's the status line, then we have the header and the body. And so the status line contains the status code and the status text. The status code is a 3-digit number that indicates the results of the request. So this could be like 404 or 503. The status text is a short text that will summarize the meaning of this code. So for example, you would usually see them in pairs, like 200, okay, 403, forbidden. The headers contain information that the client would want to use to find more about the response and about the server that sent it, and about the server that sent it. And so, for example, this is very similar to the request headers. So we see here, like the content type image slash on JPEG would basically tell the client or the browser that sent an API request that the return content of that the return content in the response of their API call is a JPEG image. The response body, as its name implies, is just the part of the response that contains the resource requested by the client, and then sometimes some other information about the status of the action that was requested. So like I briefly described earlier, status codes are 3-digit numbers that relay the results of a client's request. And so these can be broadly classified into 5 categories. So we have the informational responses that range from 100 to 199. We also have the successful responses, which basically tell the client or the who sent the request that the request was successfully received by the server. An example of this would be the status code 200, which is a standard success response that signifies that everything went okay and that the result of the request has been returned. We also have like the 201, which is the created status code, which would tell you that the request has been fulfilled and that another resource has been created in the server database. Another category that we have are the redirection messages, which range from 300 to 399. And basically, these are the class of messages that occur when there's a redirect from the request URL. And so, for example, the 301 code, which is a permanent redirect, this basically tells you that the server is redirecting you to a different endpoint. And this can happen when like the company that created an application or the API has switched their domain name or the endpoint name has changed. Then we have the client error messages, which range from 400 to 499. And this basically tell the client that there's something wrong with the way that their request was formatted. An example of this would be the very common 400 bad request, which basically tells you that the server thinks you had made a bad request, and this happens sometimes when you don't like send along the right data. There's also the 404 not found request, which means that the resource that you were trying to access like wasn't found on the server. So if you think back to the example with Enricher, if the user ID that we're trying to get information from does not exist, we would be getting a 404 status code. Then the server error responses, which range from 500 to 599, are essentially for when there's an error that's being made on the server side. A very common example of this is the 500 status code, which is an internal server error. And this is just the generic answer for when there's an unexpected server failure and there's no more specific information made available by the server as to why this happened. You can also look at the MDN web docs, which I've linked here, and this provides like a more detailed information about all the status codes that are available by APIs that have been created.